Mm. Well, I'm Professor Nadhamuni Reddy. Mm. So, in this session, we'll come to know how to solve a 3 by 3 mixed strategy games. I mean to say, when the pair matrix is given, you will be applying the rules of dominance and you will be verifying the minimax maximum criterion also whether the saddle point exists for the game or not. So, if it is reduced to the dam minimum size like this after applying rules of dominance, you can just, it is evidence that there is no saddle point for the game. Minimax and maximum if you find, there is no saddle point for the game. This is the dam minimum size which you cannot reduce further by rules of dominance. So if the size of the matrix is 2 by 2 arithmetic method, we just earlier demonstrated. The size of the matrix is a 2 by n or m by 2 graphical method we employed. Now the size of the matrix is 3 by 3. There are three alternative techniques available. Number one, algebraic method. Algebraic method. Arithmetic method applied for 2 by 2 matrix, that is different. Here this is algebraic method. Algebraic method. So in this, assume that x1, x2, x3 be the mixed strategy for the player. I mean to say, this is a mixed strategy game. You need to find out what is the probability distribution of selection of the strategies for the player A. What probability that he's going to choose one, what probability is going to choose probability that he's going to choose second strategy, with what probability is going to play third strategy, like that. Probability distribution you need to find out. Let those probabilities be x1, x2, x3. So there are three alternative strategies for him. The probabilities with which he is going to play these strategies will be x1, x2, x3. You are assumed. Similarly, player B has three mixed strategies 1, 2, and 3. Let y1, y2, and y3 be the probabilities that B is going to play with the strategies 1, 2, and 3. So, if that is the case, if you'd like to write, let a new be the value of the game. Let a new be the value of the game. The symbol new be the value of the game. Value of the game is what the net payoff to the player A. Net payoff to the player A after playing the game. That is called new. So you need to find out x1, x2, x3, y1, y2, y3, and the value of new, which is called the value of the game new. Now, if B plays with the first strategy, say if B plays with the first strategy, what will be the expected payoff to the player A? One, this payoff element into probability x1 plus this payoff element into probability x2 plus this payoff element into probability with which he is going to play this strategy. So 1 into x1 plus minus 1 into x2 plus minus 1 into x3. See here, 1 into x1 plus minus 1 into x2 plus minus 1 into x3. That is the expected payoff to the player A when player B always plays with the first strategy. So that should be the greater than or equal to new value of the game. Expected payoff to the player A. What is his expected payoff? Expected payoff must be greater than or equal to value of the game. Similarly, when B plays with the second strategy like this, expected payoff to the player A will be minus 1 into x1 plus minus 1 into x2 plus 2 into x3. That should be greater than or equal to new. Similarly, when player B plays with third strategy, expected payoff to the player A will be equal to minus 1 into x1 plus 3 into x2 plus minus 1 into x3. That should be greater than or equal to value of the game. And what is the relation between x1, x2, x3? Summation of all these probabilities x1 and x2 and x3. Three alternative strategies are there. He is going to choose these strategies. The probability is x1, x2, x3. Summation of these probabilities will be equal to 1. So x1 plus x2 plus x3 equal to 1. x1 plus x2 plus x3 equal to 1. So these are the four equations formed. See, the values of x1, x2, x3 is greater than or equal to 0. This one simultaneous equations. Four equations are there. Four equations are there. The first equation simplified like this: x1 minus x2 plus x3, x1 minus x2 minus x3 equal to new. So replace this greater than symbols by just equality symbols. Greater than equal to is there. For solving the simultaneous equations, replace this greater than equal to symbol with equality symbol. Then these three equations becomes like this: x1 minus x2 minus x3 equal to new, minus x1 minus x2 plus x3 new, minus x1 plus 3 x2 minus x3 equal to new, and finally this Probability summation of all the probabilities equal to 1. X1 plus x2 plus x3 equal to 1. So these are the four equations in four unknowns. So simultaneous equations, you can solve these simultaneous equations and find out the value of each and every variable. Five equations in five variables. You can solve the simultaneous equation to find out. I will simply tell you this first equation and the fourth equation. You just eliminate few variables. X1 minus of x2 plus x3 is there. X2 plus x3 only. In place of x2 plus x3, there in this equation, you can write x1 minus 1. So x1 minus of, in brackets, you have x1 minus 1. So x1 minus of minus x1 plus 2x1. 2x1, 2x1 minus 1. 2x1 minus 1 equal to nu. So x1 equal to nu plus 1 by 2. So this one nu plus 1 by 2. Similarly, second equation and fourth equation. Second equation and fourth equation use. X minus x1 minus x2 is there. That is minus of x1 plus x2. X1 in place of x1 plus x2, right? 1 minus x3. Or x3 minus 1. Minus of x1 minus x2. In place of minus x1 minus x2, write it as x3 minus 1. So x3 minus 1 plus 2x3 equal to nu. In place of minus x1 minus x2, write it as x3 minus 1. x3 minus 1 plus 2x3. So 3x3 minus 1. 3x3 minus 1 equal to nu. 3x3 equal to nu. x3 equal to nu plus 1 by 3. See this one. Similarly, third equation, fourth equation. Here also minus x1 minus x3 is there. Minus x1 minus x3. What becomes x1 if you send x3, x1, x3 this side, what do you get? Bring a 1 this side. So x2 minus 1. So in place of minus x1 minus x3, you write as x2 minus 1. 3x2 plus x2 minus 1. 4x2 minus 1 equal to nu. 4x2 equal to nu plus 1. x2 equal to nu plus 1 by 4. You get this. So 1 combined with 4. 2 combined with 4. 3 combined with 4. Equation 1 and 4, equation 2 and 4, equation 3 and 4. Eliminate the necessary variables, possible variables. By using this last equation, we will be getting the values of x1, x2, x3 in terms of nu. We know the relation between x1, x2, x3. x1 plus x2 plus x3 equal to 1. Once again, substitute these expressions in x1 plus x2 plus x3 equal to 1. Now everything in terms of nu. So nu can be computed as like this. Nu equal to minus 1 by 2. When you substitute the value of nu in these expressions, you come to know the value of x1, value of x2, value of x3. Value of x1, value of x2, x3 are nothing but the probabilities. 6 by 30, 3 by 30, 4 by 30. Tell me, for this man, player A, you got the probabilities x1, x2, x3. The mixed strategy for the player A is now known, and value of n is also obtained. New value is also obtained. U equal to minus value which means A will be losing something. That's the meaning of that. Similarly, for him also, for player B also you can formulate simultaneous equations. See, when A plays with the first strategy, what will be the expected payoff from B 1 into y1 minus 1 into y2 minus 1 into y3. This must be less than or equal to nu. This one, see, he is the minimizing player. As the payoff matrix for the player A is written, he is the minimizing player. Hence, he always expects that the expected payoff must be less than or equal to nu. So when A plays with the first strategy only, expected payoff to from the player B equal to this element into y1 plus this element into y2 plus this element into y3. First row into y1, y2, y3. That should be less than or equal to nu. Similarly, when A plays with the second strategy, expected payoff from the player B equal to this element second row into y1, y2, y3. That is minus 1 into y1, minus 1 into y2, plus 3 into y3. That must be less than or equal to nu. Similarly, if A plays with third strategy, expected payoff from player B equal to minus 1 into y1, plus 2 into y2, plus minus 1 into y3. That should be less than or equal to nu. And what is the relation between y1, y2, y3? y1, y2, y3 are nothing but the probabilities that player B is going to play with the different strategies 1, 2, and 3. So y1 plus y2 plus y3, summation of all the probabilities equal to 1. That's also given. y1 plus y2 plus 3. So if you consider these four equations, this is the first equation is now written like this. Second equation is now written like this. Third equation, replace less than or equal symbol by the equality symbol. And finally, y1 plus y2 plus y3 equal to. We solve these equations as solved here. I solve these four equations. You solve these equations. Y1, y2, y3 can be expressed in terms of nu like this. Summation of these y1, y2, y3 equal to 1. Substitute these expressions in y1 plus y2 plus y3 equal to 1. This you will be getting the value of nu. So here also value of the game is same. Value of the game is nothing but the net payoff to the player A from player B after playing the game. So y1, y2, y3. Substitute these new values in this expression. You're getting y1, y2, y3. I mean, optimal mixed strategy for the player B is also known. Optimal mixed strategy for the player A is x1, comma x2, comma x3. Optimal mixed strategy for the player B for the strategies for his strategies 1, 2, 3 is nothing but y1, comma y2, comma y3. Show them in braces, probabilities, and value of the game equal to mu. So you need to solve using algebraic method. Very simple method. Very simple method. Now there is one more method called the matrix method, shortcut matrix method for n by n games. N by n games and let it be any number of uh, I mean let it be 3 by 3 matrix or 3 by 4 matrix or 4 by 4 matrix, whatever it is, anything beyond 3 by 3. If you know 2 by 2 size, you know the method, arithmetic method. If you know 2 by n or m by 2, graphical method. If it is 3 by 3, algebraic method is one alternate that we have studied. Now one more method, matrix method, I would like to demonstrate. Another method, LP method also there. So compared to the LP method, is algebraic method and the matrix method is they are easy. So in this matrix method, say this step-by-step procedure is there. You can go through the step-by-step procedure. I will directly explain with the help of an example. See, this is an example. See, solve the following game by using shortcut matrix method, some simple matrix method. Sometimes method will not be mentioned. First of all, you verify whether the rules of dominance are applicable here. Any row is dominating another row. No row is proved to dominate the other row. And similarly, no column is proved to be dominating the other column. So in that case, by applying rules of dominance, you cannot reduce the game. That's the first aspect. Second aspect is whether the game consists of the saddle point. I mean, minimax, max, mini criterion you must apply. So if you apply minimax criterion, first row minimum is 1 row minimum. Second row minimum minus 1. Third row minimum 5, 7, 6, 5. Of all these row minimum, maximum value is 5. So 5. Similarly, column maximum. Coming to columns, you write the maximum of the column. 7, 9, 5, 9. 1 minus 1 is 7. 7, 1, 6, 7. So of all these maxima, minimum value is 7, 7. So maxi mini is 5, mini max equal to 7. They are not equal. Hence, there is no saddle point for the game. So rules of dominance did not help us to reduce the game further. And saddle point, there is no saddle point for the game on applying the minimax maximum criteria. It is understood. So you need to find the solution for the mixed strategy game. So when there are no pure strategies, which means that it is a mixed strategy game, you need to find out the solution for it. So take this matrix as it is. The matrix you see 7, 1, 7, 9 minus 1, 5, 7, 6. So here subtract the second row from the first row. Right here. Second row 9 minus 1, 1. First row 7, 1, 7. Subtract second row from the first row. Write the element results here. 7 minus 9 minus 2. 1 minus of minus 1 plus 2. 7 minus 1, 6. Similarly, subtract third row from the second row. What do you get? 9 minus 5, 4. Minus 1 minus 7, minus 8. 1 minus 6 minus 5. So what is that order? Subtract second row from the first row, third row from the second row. You got those results. Similarly, columns if you see, subtract second column from the first column. Second column from the first column. 7 minus 1, 6. 9 minus or minus 1, 10. 5 minus 7, minus 2. Like this. Similarly, third column from second column if subtract. Subtract third column from second column. 1 minus 7, minus 6. Minus 1, minus 1, minus 2. 7 minus 6, 1. Like this, you return the results here. Now you see, you need to find out the determinants of oddments for the different matrices, different I mean 2 by 2 matrices that you are going to form. When you write the determinant here for this column, this you should not consider. Only this matrix you need to consider. 2, 6, minus 8, minus 5. 2, 6, minus 8, A1, 1, 10 minus 2. Where is that 10? This one, you see. If you like to write this one, if you like the determinant here for this row you should not consider this row. So 10 minus 2 minus 2, 1. That is the what you call determinant you should find out for this matrix and write the result here. So even if you would like to write for the first row determinant, ఇక్కడ రాస్తాం ఇక్కడ రాస్తాం 38 6 okay that will tell you 38 ఇక్కడ రాస్తాం right. They will be super, they will what you call transposed. So if you like to write for this, what is to be done? You need to consider this one 10 minus 2 minus 2 1. A1 say A1. Similarly, if you like to write the value for this, you need to consider this row 6 minus 6 and minus 2 1. 6 minus 6 minus 2 1. Call it as Newton. The determinant is nothing but this one 6 into 1 minus of this value into this value. So you need to find out. So 10, okay. 12 minus 6, right? This one, this minus this. Similarly, if you like to write the augment for this row, what do you write? You must leave this one 6 minus 6 so 10 minus 2 10 minus. So ఇక్కడ ఏమొస్తాయి మీకు 6 6 48 వచ్చింది. ఆ 6 6 48 ఇక్కడ రాస్తాం 6 6 48 ఇక్కడ రాస్తాం 6 6 6 48. Same way, if you like the augment for this column, ఈ కాలంకి రాయాలంటే ఈ వదిలేస్తాం, ఇది మాత్రం కన్సిడర్ చేస్తాం. 2 minus 8 6 5 2 6 minus 8 minus 5 ఇది మాత్రం దీన్ని వదిలేస్తాం. దాని ఏమొచ్చింది 38 వచ్చింది. 38 must be written here. సో ఈ సెకండ్ కాలంకి ఆర్గ్మెంట్ రాయాలంటే ఈ వదిలేస్తాం, ఈ ఎలిమెంట్స్ వదిలేస్తాం. -2 4 6 minus 5 ఇది -2 4 6 minus 5. దీని డిటర్మినెంట్ వస్తుంది -2 into -5 that is 10 minus of 24, sorry 6 into 4 24 minus of 10, this one 14. Similarly, if you like to write the augment for this, you leave these elements, consider these columns only. -2 4 2 minus 8. So like that you will be treating the augments. Carefully observe how the 2 by 2 matrices are formed and determinants are found. You will be getting A1 A2 A3 to write here. These are the values A1 A2 A3 augment for A1 A2 A3. Similarly, augments for B1 B2 B3 38 14 8 వస్తాయి. So if you sum up these values, both will be equal 60 or so. So any further reduction is possible. Here every value is divided by 6 by 6 6 by 6 48 by 6 118 or so. But this can also be reduced. 4 కాదు 7 2 తో చేయొచ్చు. 8 by 2 14 by 2 38 by 2 97 4. సో వీటిని ప్రాబబిలిటీస్గా రాసేయడం. హౌ టు రైట్ దీస్ థింగ్స్ ప్రాబబిలిటీస్గా రాసేయడం అంటే ప్రస్తుతం దిస్ వన్ టోటల్ సమ్ ఈస్ 10 1 plus 1 plus 8 10. So 1 by 10 8 by 10 ఇవి ప్రాబబిలిటీస్. సిమిలర్లీ ఇక్కడ 19 plus 7 plus 4 26 30 వస్తుంది. 19 by 30 7 by 30 4 by 30 ఇవి probabilities. So these are the probabilities for player B. These are the probabilities 1 by 10 1 by 10 probabilities for player This is how mixed strategies are to be formed by. That's all. So this is also one of the easy technique to find out. Matrix method is one of easy technique. Carefully just observe these things. Is nothing difficult. You can very easily do it. If it is 3 by 3 matrix, solving it in a matrix method is so easy that within no time you'll be able to do it. It won't consume much time. The algebraic method, though, if you compare this method with the algebraic method, this is proved to be, more efficient, and you can do it very fast. So these two methods you can rely on. Any one of these methods you can rely on to simply do 3 by 3 games, 3 by 3 mixed strategy games. Right. Okay. Now, my sincere advice is that any game is given, if it is directly given, it will be in the form of payoff matrix. You need to apply the rules of dominance to reduce it to the dam minimum size, and then minimax max criterion also shall be applied to the minimum matrix you obtain. If there is a saddle point, there itself solution you will be getting. If there is no saddle point for the game, that matrix is called a mixed strategy game. You need to apply a suitable method based on the size of the matrix. If it is 2 by 2, reduced size of the matrix is 2 by 2 and no saddle point for the game, go for arithmetic method. If it is 2 by m or m by 2, go for graphical method. If it is 3 by 3 matrix, if the reduced size of the matrix is 3 by 3 and there is no saddle point for the game, if that is the size of mixed strategy game, either 3 by 3 or 3 by 4 or 4 by 4, what are bigger sizes beyond 3 by 3 there, which is equal to 3 by 3 or beyond 3 by 3 is there. Three different methods are there. One algebraic method I just explained earlier. Now is matrix method also explained. Then one more linear programming method is there. That I will do it in the next session. If unless otherwise it is mentioned, better solve it in the algebraic method or in this matrix method. Okay. My idea is that in the previous session shown many formulations, many problems of exercise problems are also there, and just understand how to formulate the payoff matrix and do at least two problems for each and every method. 2 by 2 ఉన్నవి ఒక two methods, two problems. 2 by n, 2 by 3 2 by 4 ఉన్నది ఒక problem, and 3 by 2 like 4 by 2 ఉన్నది ఒక matrix, graphical method. Then 3 by 3 ఉన్నవి, take two more problems. You will get in practice. Within no time you will be able to do it. You follow either matrix method or the previous method, algebraic method. Thank you. Thank you. Thank you.